You are welcome to this video. So in this video we're going to look at how to make a chemical formula. Okay, how to make a chemical formula. This is the very important topic in chemistry. If you miss this one, then chemistry will be difficult for you, because almost all the questions in chemistry, they involve chemical formula. So it is like it is a foundation. So you need to know how to make a chemical formula. So now, what is a chemical formula? Okay, so what is a chemical formula? So a chemical formula is simply a representation of the number and types of atoms present in a compound. Okay, it is a representation of the what? The number and what? Types of what? Of atoms that are present in a compound. The representation of what? The number and the types of atoms that are present in a compound. So what are we really talking about? What are we talking about? For example, we have a chemical formula of let me say sodium carbonate. Okay, so sodium carbonate is like this, sodium carbonate. Okay, so this is actually a chemical formula of what? Sodium carbonate. So now we have said that a chemical formula, it is a representation of the number and the types of atoms present in a what? In a compound. So this is actually a compound. Okay, this is a compound. The compound is a combination of two or more atoms. Okay, so now here we're saying that it is a representation of the number of atoms and the types of what? The types of atoms. So here we have three types of atoms. There is sodium, there is what? Carbon, there is oxygen. All right, how about the number of atoms? So the number of atoms here, we have how many atoms? We have two atoms of what? Of sodium. We have one atom of carbon. We have three atoms of what? Of oxygen. So a chemical formula, it is a representation of the number and types of atoms present in a compound. So that is what a chemical formula is. Okay, so that is what you need to know about the definition of a chemical formula. Make sure that you are understanding what I'm actually talking about here. So that is what a chemical formula is. Okay, so now, how did we come up with this chemical formula? How did we come up with that? Okay, so now what you need to know is the valence number. Okay, so you need to know what a valence number is for you to know how to make a chemical formula. Okay, so now what is the valence number? What is a valence number? So the valence number, okay, valence number is actually the number of electrons. Okay, the number of what? Of electrons. The number of electrons. Okay, a number of electrons an atom can share. Okay, it is a number of electrons an atom wait atom, it's like this. Okay, it is a number of electrons an atom can actually gain, okay, gain, loss, or share in order for it to be stable. Okay, so in order for it to be what? To be stable. A valence number is the number of electrons an atom can gain, lose, or share, can either gain, lose, or share for it to be what? To be stable. That is what a valence number is. What do I mean for it to be stable? What do I mean? Okay, so it means that when the atom is stable, it will no longer react with any other what? Any other atoms. Okay, so like for example, we have this is a periodic table. Okay, this is a periodic table here. So these ones which are at the end, okay, these ones which are at the end, they are actually stable. These ones, they are actually what? They are stable, but there are atoms that are not stable. For example, we have let's say we have lithium here. Okay, so we have lithium here. So lithium here, so this is the lithium, it has this. Okay, so the symbol for lithium, it is actually, let me just try to create some space here. I show you what I'm really talking about. Okay, lithium. Lithium is too simple. Let me just pick let's say oxygen. Okay, so oxygen, the way oxygen is, it is like this. Okay, so oxygen, there is 16 here, there is what? There is 8 here. Okay, so there is 8 there. So now during bonding, you actually learned that this is what? The proton number. This is what? The mass number. So for you to know how many electrons, or for you to know what is the valence number for what? For oxygen is, what you need to do during bonding, you were actually saying that the configuration for this one is like this, right? If you remember this. So you are saying that this represents the number, the shells that are present in a compound, in actually the atom. So this is the first shell, second shell, third shell, fourth shell, going on like that. So the first shell, it is full with what? With 2 electrons. Okay, the first shell is full, it's supposed to be full with 2 electrons. Then this has to be full, these others, they have to be full with how many? 8 electrons. So this is oxygen. This is the number of electrons here, or the proton number. So what we do to make this configuration, we say we subtract the 2, which is the 2 for the first shell. How many are going to be here? So 8 minus 2, that is equal to 6, meaning that there will be what? 6 electrons here. Okay, so there are 6 electrons here. So it's supposed to be full with how many electrons? The second shell is supposed to be full with what? With 8 electrons. So now, how many electrons does it need for it to be full? This is 6, and how many electrons does it need for it to be full or to be stable? So the second shell has to be stable with how many electrons? 8. So we have 6, meaning that it needs 2 electrons for it to be stable. Okay, for it to be what? To be 8. So meaning that this, it needs how many? It needs 2 electrons for it to be stable. I hope you are getting the meaning. So let me do this. So this is actually oxygen, the atom of oxygen, right? During bonding, we are doing this. You remember, during bonding, you are saying that this first shell, it has to be full with how many? With just 2 electrons. And we have these ones, they are how many? 6. So 1, 2, 3, 4, 5, 6, right? So now this whole cell, it needs shell, it needs how many? It needs 2 electrons for it to be stable. That is what I mean. So now those electrons that it needs, they are what we call valence number. That is the valence number. The number that this atom requires. To require is to what? Is to gain. Okay? So the number that the atom requires for it to be stable, it is called the what? The valence number. Alright. So now, I'm sure you know what a valence number is. Okay. So now, what I'm going to show you before we start to make a chemical formula are the atoms on the periodic table. And I'll actually show you the number of electrons. Okay? I mean the number of what? The valence numbers. Okay? So this is actually group 1. This is group 1, group 2, group 3, right? Group 4, 5, 6, 7, 8. Okay? So now what you need to know is that, okay, so what you need to know is that the valence numbers of those that are in group 1, they have 1. That is a valence number. Okay? Those that are in group 2, they have 2. That is the valence number. Okay? Those in group 3, they have 3. That is the valence number. In group 4, they have 4. Okay? So they have what? They have 4. Then here, group 7, they have what? 1. Group 6, they have 2. Here, 3. Okay? So these are the valence numbers here. We said that the valence number, it is a number of electrons that an atom can gain, lose, or share for it to be what? To be stable. That is what we said. Okay? So, what you need to know is this. So this is how you can do it. So we say 1, 2, 3, 4. When you open your past paper, you just say, when you open your periodic table, you just say 1, 2, 3, 4. Then you come here, you start 1, 2, 3. So these, they have the valence of 1, they have the valence of 2, 3, 4, 3, 2, 1, just like that. Okay, just like that. Okay, so now how about these ones? These are the transition metals, right? Transition metals. Transition metals. So now these ones which are here, their valence numbers, they just specify. Like they will say cobalt 60. Okay, when they say cobalt 2, lead 4 or lead 2, okay, they will say copper 2, just like that. That means that copper, they want it with what? The valence of 2. That is what they do for them to give when they give you this. So they just specify. But you need to know that these ones in the first group, they have 1, 2, 3, 4, 5, 6. Oh, 1, 2, 3, 4, 1, 2, 3, just like that. Okay, as simple as that. I hope you are getting it. Okay, you need to understand this. Are we together? So now that we know that we know these valence numbers. So these are the valence numbers that are in the last shell of an atom. Okay, these are those numbers that are in the last shell of an atom. That is what we call the valence numbers. So like for instance, this is beryllium, right? Beryllium like this, beryllium. So how many electrons does it have? So it has what? It has 4 here. It has 4 electrons, right? Now, how do you know that it has this, because we are saying that it has 2 electrons in the outer shell. So how can you know? You know that the first shell has to be filled with what? With 2 only. So now there is 4 here. How many left? We have what? We have 2. Okay, so that is what you need to know. This is in the last shell. If you were to draw this, you say beryllium like that, 1, 2, then 1, 2 like that. Okay, so that is how you do it. So now, how to make a chemical formula. So a chemical formula, it is just a representation of number and the types of atoms. So for instance, if you have been taught to make a chemical formula of what? Of beryllium and oxygen. Of beryllium and what? And oxygen. Okay, so beryllium, here is beryllium. Beryllium has a valence of what? Has a valence of 2. Okay, so beryllium has a valence of 2 and oxygen has a valence of what? Oxygen is here. Oxygen has a valence of 2. So they both have the valence of 2. So what you do now is you get beryllium like this. So this is beryllium. Then you come here, you get what? Oxygen. Okay, so beryllium has a valence of 2. So you say 2. Oxygen has a valence of what? Of 2. So what you do is you swap their valences. So this 2 comes here, 2, then this 2 comes here, this 2. Okay, so now what you need to do is to divide by the common factor. So the common factor here, it is a number that can go in both numbers without leaving a remainder. That's 2. Okay, so 2 can go in this, 2 can go in that. So here it will be 1, here it will be 1. So meaning that you have how many atoms of beryllium? You have 1 atom of beryllium like that. Then how many atoms of oxygen? You have 1. So meaning that the chemical formula, it will be like this: beryllium oxide. Okay, now what about sodium oxide? When you hear sodium oxide, it is actually a combination of sodium and oxygen. So sodium and what? Oxygen. So when you're taught to make a chemical formula for that, so what you say, this is our sodium, and sodium is actually in group 1. Okay, so mean that it has a valence of what? It has a valence of 1. Okay, so when you come to oxygen, it has a valence of what? Of 2, you know. So you just put 2 there like that. So you swap their valences. Okay, so when they swap their valences, mean that the 2 comes to sodium, the 1 comes to what? To oxygen, like that. Okay, from here now you divide by the common factor, which is a number that can go in both without leaving a remainder, which is over 1. Divide by 1 like that. So meaning that when 1 goes in that, it will be what? 2. 1 goes in that, it will be what? 1. Right? So meaning that what you are going to have is you're going to have sodium with how many electrons, or with how many atoms? It's 2. So you're going to put it down there. Then oxygen with how many electrons? With the 1. So but since it is 1, just don't put 1. Okay, you just one and the same as saying 1x. That is what it means. So now this is a chemical formula for what? Sodium oxide. Okay, sodium oxide. So that is a chemical formula. Make sure that you watch this full video, because I'm going to be doing the chemical formulas together with the radicals. So you need to understand what I'm going to do. Make sure that you watch the full video. I'm just trying to give you examples here. Okay, so for example, let's have another example. We have let's say we have calcium. Okay, we have calcium like that, calcium, And I would say boron. I would say carbon. Should I say carbon? Carbon. Let me get okay, first let me show you something before I solve all these things. So what you need to know is that you need to know where are the metals and where are the non-metals. So metals are actually here, okay? Right here, like that, like that. This is the demarcation of metals and non-metals, okay? So this is the demarcation here, okay? This is the demarcation of metals, okay? So these are the metals, these are the non-metals starting from here, okay? So metals combine with what? With non-metals, not metals to metals, no. Okay, so this is what you need to know, is that the chemical formula is between metals and non-metals, or just among metals, okay? So the metals can combine, or the non-metals then combine, they can combine, okay, but the metals they cannot combine. Like magnesium, calcium, no, they can't combine. The metals they can't combine like that, okay? So they're supposed to be any other what? Non-metal. Are we together? Okay, so let's get, so you get a metal and a non-metal for you to make a chemical formula. For example, like I said, let's get calcium, okay? Calcium, that's the calcium here. Then I would say boron, okay? Boron, let's say boron. So we have boron. Boron, you know that it has a valence of what? The valence of 3, okay? Boron has a valence of 3, so you say boron, okay? It has a valence of 3. Calcium has a valence of 2 since it is in group 2, so you say they swap the valences like that, so mean that the 3 will come here, the 2 will come there. The number that can go in this, it is just 1, and meaning that they'll be the same, so meaning that we are going to have calcium 3, then boron 2, just like that, okay? So that is how it is going to be. So now let's look at a chemical formula that involves radicals, okay? So these radicals, these are the radicals, okay? So these are actually the radicals that are common in chemistry, okay? So you need to know what a radical is. A radical is actually a group of atoms, okay, that can exist together, or that can exist together and cannot exist on their own, or should I say independently. They can't exist on their own. Like hydroxide, you won't find it like you find it like this, hydroxide, just like that, okay? Hydroxide, you won't find it just like this, hydroxide. You won't find sulfate just like that on their own, no, just like that, no. You won't find oxygen 3 just like that, you understand? So you need to know their valence numbers by heart, because these valence numbers, you won't find them on the periodic table. You won't find them that a combination of oxygen and hydrogen has a valence of 1. You won't find them, because what you know is that oxygen has a valence of 2, hydrogen has a valence of 1, okay? So you won't know what the valence numbers are if you won't master these, or you won't know or study these by heart. So I want you to know these by heart, okay? That's why I've brought them here. All right, so you need to know that how to write hydroxide. So hydroxide is to write it as OH. Then you need to know that it has a valence of 1. Sulfate, like this, SO3, and it has a valence of 2, just like that. So all these, so we are going to use them. So let's say we are combining, let's say hydroxide and sodium. Okay, sodium hydroxide, the combination of sodium hydroxide. What is the chemical formula for sodium hydroxide? So you know that sodium is in group what? Is in group 1 sodium. Check on your periodic table. Sodium is in group 1, meaning that it has a valence of 1. Okay, so how about hydroxide? So this is hydroxide. Okay, that's how you write hydroxide, and it has a valence of what? Of 1. So make sure that you know them, because they won't bring for you these. You need to know the valence numbers. So the valence number of hydroxide, it has a valence of 1 as well. So when they swap the valences, we are going to have sodium 1 and hydroxide 1. So this is the sodium hydroxide, which is one of the strong base. Okay, so you need to know this. You need to know how to make a chemical formula. So now let's take it for example. We have been taught to make a chemical formula for potassium. Okay, potassium, it's capital K. Potassium, like that. So potassium is in group 1. If you check your periodic table, it has a valence of 1. Hydroxide, you know that has a valence of 2. When they swap like that, they'll just be potassium hydroxide, just like that. Okay, as simple as that. All right, so now when you put calcium, okay, when you put calcium, so calcium has a valence of 2. Make sure that you understand here, because that's where they make mistakes here. Calcium has a valence of 2, hydroxide has a valence of 1. So what you need to do is to swap the valences. Okay, when you swap the valences, this will be 2, this will have 1, like that. Okay, that will have 1 like that. So now this will be what? It will be calcium 1. Okay, it will be calcium 1, which is just like that. Then what you need to know is that whenever a radical is receiving more than 1 electron, whenever a radical is receiving more than 1 electron, meaning that starting from 2 going up, the number of electrons, if they are 2 going up, put the radical under a bracket. Okay, put it inside a bracket. That is what you need to do. So it will be oxygen, hydrogen, like that. Then the 2 will be outside. Okay, so put it under a what, or inside a bracket, but put the number of electrons that it is receiving outside. Okay, that is what you need to do. Okay, whenever it is receiving more than 1, make sure that you do this. Okay, so for instance, we have let's say we have aluminium. Okay, aluminium, it is a metal, aluminium, and when you go on aluminium on the periodic table, you find that it has a valence of 3. Okay, so let's say you are combining it with sulfate. Okay, with what? With sulfate. So sulfate is written like this, SO3. So sulfate, it has a valence of what? Of 2. So this, it is part of the formula. The 3 is part of the formula, so that is what you need to know. So when these swap their valences, Okay, I'm doing it slowly here so that you understand. When these swap their valences, meaning that the 2 will come this side, the 3 will come that side. Okay, so meaning that the metal here, aluminium, will be aluminium 2 like that. Then this radical, it is a radical, and what I said is that when a radical is receiving more than 1, you put it inside the bracket, so mean that it will be inside the bracket. So it is so sulfate like that, SO3. Then what is, so these three will come outside like that. So this is a chemical formula for aluminium sulfate. Please make sure that you pay attention to this, because you need to know this. All right, so they will be coming in an exam, so you need to know this. This is actually goes to what we call this is what we call, this is where we come up with the what, the let's say a chemical equation. Yes, a chemical equation. So if this is plus like that, so meaning that it will be equals to what? It will be equals to aluminium. You know that this will gain a 3 or gain a 2. Okay, it will have a 2 here, then sulfate like that. Okay, so this is where we'll be going. This is how it will be. All right, so make sure that you understand this, because it all starts from chemical formula. So you need to know how to make a chemical formula. So which one are we going with? Actually, this was supposed to be carbonate. This is carbonate. It has there's CO3 there. Okay, carbonate has CO3. So if we say carbonate, a combination of carbonate and what metal are we going to choose on the periodic table? So we are going to choose, let's say, well, let's choose potassium. Okay, potassium carbonate. So potassium has a valence of 1, carbonate has a valence of what? Of 2. Okay, so you need to know this. So it has a valence of 2, so when they swap their valences, meaning that here we have 1, here we have 2, so meaning that when we divide by 1, you know, you're going to have potassium, 2 atoms of potassium, then the valence number that is coming to carbonate, it is just 1. Okay, it is just 1, meaning that you won't put it under a bracket. It is not more than 1. It is 1 itself, so mean that it will be like this. So this is a chemical formula for potassium carbonate. Okay, so I've actually done a lot of chemical formulas, how to make chemical formulas. Make sure that you understand. Make sure that you understand these things, because they are important. Okay, they are important as we go, or when you are solving a past paper or anything concerning chemistry, they are important. So when you get all these, you do the same things, you find what I am saying. So make sure that you understand this video. When you have a question or you want to start tuitions, you can actually WhatsApp me on this. So we are actually Exam Standards online tuitions. Okay, I'm your tutor, Patrick Divine. Make sure that you follow for more. Okay, so that's all for today. Thank you.